We've already seen one way of describing a plane in 3D space. In this video, we're going to look at another way of describing a plane in 3D space. But before we do, let me just remind you, two vectors are perpendicular to each other if the dot product equals 0. So we've already seen this, so I'm asking you to accept this. Remember, are perpendicular to each other if the dot product equals 0. We're going to make use of this later on. So let's say you've got a, let's say you have 3D, let's say you have 3 points. Let's say you have 3 points. If you have 3 points, then you're always going to be able to create a plane or in 3D space. So suppose this, suppose this point here is here. So now you've got three points here. Whenever you have 3 points, you can always create a plane. Here you've got yourself a plane here. Even if you have, let's say this, you've got this point, and this point here. Then with 3 points, you're always going to be able to create a plane. So let's say you've got 3 points here. With 3 points, you can also create 2 vectors because you can always get this vector. Well, with 3 points, bear with me. With 3 points, you can always create 2 vectors because this vector here, you can just get this point, take away this point. So that will then give you this vector here. And then with 3 points, you can always get this point, take away this point, then that will then give you this vector here. That will then give you this vector here. So with 3 points, you can always create 2 vectors. So with 2 vectors, so this vector here, so this is P1, P2, and then from here to here, so from here to here, this here represents the vector, and then this here represents a vector. So with 2 vectors, if you perform the cross product, remember we've seen this many times. If you blindly perform the cross product of 2 vectors, it's going to give you a new vector, and this new vector is always perpendicular to the other 2 vectors, to this vector and to this vector. And we've seen this many times. I'm asking you to accept this because if you get one vector, cross it with another vector, it's going to give you a new vector, and this vector here is perpendicular to this one and this one. We've seen this many times. So here's a way of describing a plane in 3D space. If you have a general point here, well, this you can always work out this vector here. If you want to describe a plane, you demand that this vector here to be orthogonal to the normal vector here. So hang on, let's start again. So this is our vector here, and then this is our vector here. Perform the cross product. That will then give you this vector here. That will then give you this vector here. Now, if you look at your general point here, from here to here, so that's from P1 to your general point P with a blank here. So this here represents this vector here. Now, if you demand that this general point to be perpendicular to this vector here, then it will lie on the plane. You see, this point here will be perpendicular to our normal one. So the thing is, you demand this vector here to be perpendicular to this vector here, meaning. Remember, to detect if something's perpendicular to another vector, we would perform the dot product. Remember, I asked you to accept this. If 2 vectors are perpendicular to each other, if the dot product equals 0. Now, you've got a vector here, and you've got your normal vector here because you've just performed the cross product. You demand that this vector here to be perpendicular to this vector here. So perform the dot product. So get your vector here. So let's start again. This vector, cross it with this vector. That will then give you, so this whole thing here will then give you your normal vector. Now this vector here is this vector here. So now now take the dot product of this vector here, with this vector here, and then demand that they're perpendicular to each other, meaning the two must equal 0. So demand this point here to be perpendicular to this point. As it turns out, if you select this point here, it would not satisfy because it's not perpendicular. If you select this point here, so you've got your normal point, you've got your normal vector here. If you select this point here, so this is your general point in space here. So this thing here will be this. Now, because this is not perpendicular to this, because the determinant will not be 0. But if you select a point on the plane, then this point here will be perpendicular to your normal vector. So therefore, this point here will satisfy its being on the plane. Whereas if you select some point up here, it will not be 90 degrees. So therefore, this point is bad. This point out here will be bad. This point out here will be bad. But then this point here will be good because it will be 90 degrees to the normal. This point here will be good because it will be 90 degrees to the normal. And then it turns out all the ones on the plane will satisfy this condition. I will give you an example in the next video, and then it will be a lot clearer, I hope. Okay?